Now in this class, we'll be discussing about Pauli's exclusion principle. Based upon the values which we are going to get in this Pauli's exclusion principle, we can tell what element it is, it comes under which group, which period also we can tell. Now Pauli's exclusion principle. What is Pauli's exclusion principle? It states that Pauli's exclusion principle states that no two electrons in an atom can have all four quantum number values same. No two electrons in an atom can have all four quantum number values same. This is a statement of Pauli's exclusion principle. Okay. So, what is this, sir? We are not understanding. Just the statement is okay. Then please explain with an example. Means I will go with an example like best example in whatever the level you read chemistry, whether it is 10th class chemistry or inter chemistry, or if you go to some other levels. The basic example will be given is helium. So we got helium, which comes under inert gas. It is having duplet configuration. Helium comes under inert gas. It has got a duplet configuration. Remember this. Because all the inert gases except the helium, remaining all what we have is neon, argon, krypton, xenon, radon and afghanistan. Helium is a duplet. Neon, argon, krypton, xenon, radon and afghanistan. They all are having a octet configuration. Nothing but the outermost shell NS2 NP6. Whereas only helium is having configuration is 1s2 duplet. Okay. Now in this helium, if you observe this 1s2, here 1 denotes n is equal to 1. N is equal to 1 shell. S is nothing but a type of subshell. Nothing but a S orbital here. S is a type of subshell. Now, and before that, I will write like this, then you will understand more easily. Helium, atomic number is, very clear understanding purpose I am writing like this. Helium, atomic number 2, configuration is 1s2. In S shell, subshell, we have 2 electrons are there. This is S orbital. Okay. Now for first electron and second electron, I am writing all 4 quantum number values. First quantum number is N, principal quantum number. Second quantum number is L, azimuthal quantum number or angular momentum quantum number or subsidiary quantum number. Next is ML, magnetic quantum number. Next is called spin quantum number. Now I will write all these quantum number values for the first electron. Okay, of helium. 2 electrons are there. If I show very clearly, this is the 2 electrons. So both the electrons comes under first shell only. N denotes type of shell, that is 1, 1. Here 1s2 configuration. N is nothing but 1 only. And S subshell, L is equal to value for this is 0, 0. And ML value is also, because ML value depends upon L value, we are having a formula. ML is equal to L plus 1, nothing but 2 into L value is how much? 0 in both the cases. 0 plus 1 is equal to how much? 1. Okay, only one value will come. That is the value is only 0. That is 0. Here also 0. And MS value, in this 2 electrons are there with anti-parallel spins. One will spin in clockwise, one will spin in anti-clockwise. The electron is spinning in clockwise direction, upward arrow you know that, and the value is plus half. And the electron is spinning in clockwise, anti-clockwise direction, clockwise is plus half. Downward arrow, anti-clockwise, like this, downward arrow, and the value is minus half. See, for both the electrons, N value is same, L values are also same, ML values are also same, whereas spin quantum number values are differing. This is plus half, this is minus half. So I hope you all satisfied with the statement what I wrote on the board. No two electrons in an atom can have all four quantum number values same. So these are same only, these are same only, these are same only, but these two are differing. This is plus of and it is minus of. Okay. I hope you all understood this example. Sir, can you write the quantum number values for another element? Okay, you can write for any element, for any two electrons present in a particular orbital. Example, P has got suborbitals are there, Px, Py, Pz. Okay, so even for that, I will go with one example like aluminum I write. Okay, for aluminum. Okay, otherwise, silicon I will write. Silicon, atomic number is 14. Configuration if you write 1s2, 2s2, 2p6, 3s2, 3p, how much? 2. So if you want, you can write for this one or this one or this one or this one, anything you can write more easily. Okay, I will write for 3s, 3s2. Okay, now this 3s2 configuration I am going for this particular configuration I am going to write here 3s2. Now n value, L value, ML value and MS means principal quantum number, angular momentum quantum number, magnetic quantum number and spin quantum number. N is equal to how much in all these cases? N is equal to 2 electrons. Now here we got 2 electrons, first electron and for second electron. Both the electrons comes under third shell. N is equal to 3, 3, 3. L is how much? I told you, if L is equal to 0, which orbital, which subshell will come? S. That is, L is equal to 0, 0 because S is there. And if L is equal to 0, ML will become 0 automatically, that is this one. And for MS, 2 electrons there, one will spin in clockwise like this, upward arrow value is plus half. Another electron is downward arrow means nothing but anti-clockwise, minus half. See, these two values are same, but both the electrons were same, but these are differing. Understood? Okay. In whatever the examples you take, always the spin quantum number values will differ. Remaining may come same. Okay. Next, sir, you write for 3p, sir. 3p we got 2 electrons being not completely filled. No, we'll go with the argon, where you will understand more easily. Or argon case I will write, then you will understand. It will become, it will be the last example to explain for this particular principle. Now argon, atomic number is 18, configuration 1s2, 2s2, 2p6, 3s2, 3p6. Now I will be writing for, in 3p, we are having a orbital level configuration. In 3p types are there, 3px, 3py, 3pz, each containing, according to Hunsul, we are going to follow here, that is, we are going to fill one electron and only pairs. Now I will write the quantum number values for this is 3px2, 3py2, 3pz2. Now we are having, I am going to write the quantum number values for 3pz2. Okay, you can write 3 for 3px, 3py, 3pz, anything. So 3pz2, 2 electrons are there. For them, I am going to write 3p6 is the configuration. In that, we are going to opt 3pz2 orbital. So in 3pz, we have 2 electrons are there. So first electron and second electron. Now I will be writing N value, L value, ML value and MS value. N is equal to how much? Here is 3. N value. Now N is equal to 3. Here also N is equal to 3. L is equal to P orbital. So L is equal to 0 means S subshell. L is equal to 1 means P subshell. So we got L is equal to how much will come means that is a 1 here. 1 here also 1. Understood? Okay. So next, clearly if you write, will go the minus 1, 0, plus 1 like that. 1 will come. The number of values actually comes under this is ML is equal to 2L plus 1 values. 2 into how much here is, that is 2 into 1, that is 1 plus 1, how much? 3. That is a Px, Py, Pz. The values will come negative to positive. Minus 1, 0, plus 1. So I'm writing this one, that is plus 1, 1, 1. Now, sir, ms, two electrons are there. One spins in clockwise. That is clockwise, upward arrow plus half. Anti-clockwise, downward arrow minus half. See, n value is same, L values are same for both the electrons, and even, okay, ml values are also same, whereas ms values are differing. Only always the spin quantum number value is differing. Understood? Now I will go with one example. By giving the values, you have to identify what element it is. We can identify based on the values. Okay. Now, for example, if I give the values of quantum number values as n is equal to, okay, 1. N is equal to, okay, I will change this. N is equal to 3. L is equal to 0. Okay. EML is also equal to 0. And EMS is equal to plus half. If I say, you can identify what element is it is. Sir, N is equal to 3, I will write 3. L is equal to 0 means I told which orbital, which subshell will come means yes. Okay. ML value is also 0. Okay. Now MS is plus half. I will write the configuration as 3s1. Now before this we have some more configuration representation, that is 1s2, 2s2, 2p6. What is coming? 3s1. Now 3s1 is the last one, and here is, we got how many electrons total? 2 plus 2 plus 6, 10 plus 1, 11. That is 11. Which element it is? Sodium. Atomic number is 11. 11 electrons, atomic number is 11, and the element name is sodium. Like this. Based on the quantum number values also, we can able to identify what element it is. Sir, can you please tell this group number, sir? This is 3s1, sodium. It is a metal which comes under first A group. Understood? First A group. And it comes under, this tells about number of electrons, tells about group number, and this tells about what period it belongs to, means third period, and first A group. And the element is sodium. Sodium, you know well, it is a metal. Okay. So like this, we can understand the concept of Pauli's exclusion principle. Sir, can you please write down the values of quantum number values for different shells and orbitals and all those things? Means I will write at least 2 levels. Now if I say n value, I am writing L value, ML values, how many will come, MS how will come. Now for example, n is equal to 1 means shell number 1. Very clearly, if you want, I will write K shell. N is equal to 1 means L will become 0. We are having a formula, L is equal to n minus 1, L is equal to 1 minus nothing but 0. L is equal to 0 means S subshell. L is equal to 1 means P subshell. L is equal to 2 means D subshell, and so on. Now ML value, sir. ML value is nothing but a 2L plus 1. They start from negative to 0 positive. So now for a given L value, for example, L is equal to 0, if I substitute here, L is equal to 0, if I substitute in this formula, it will become ML is equal to 2L plus 1, 2 into 0 plus 1, nothing but 1. So ML value is 1 only coming. That is because L value is 0, na? Only one value is possible, that is a 0 value. Because if you write minus 0 plus 0, 0, anything will be 0 only. Next, for this particular value, now if you write the spin quantum number, okay, 2 orientations are possible for S subshell containing 2 electrons, S orbital, plus 2, plus half, the electron spins in upward direction, electron spins in clockwise direction. The electron spins in anti-clockwise direction will become minus 1 by 2 and downward arrow, this is anti-clockwise. Understood? Now sir, one more, for one more value will you write sir? Means I will write C. Now if I take n is equal to 2, okay, and n is equal to L shell, this is n is equal to nothing but L shell only. L value, L is equal to n minus 1, L is equal to 2 minus 1, how much? 1. So ml values, how many are possible, sir? 2l plus 1 is the formula if you substitute for ml. Okay, 2 into 1 plus 1, how much? 2 plus 1, how much? 3. Sir, so subshell is a P. Okay, so how many values are? 3 values are possible. They starts from, we got L is equal to 1, now you substitute that. L is equal to 1 means, based on this, minus 1, 0 plus 1. Minus 1, 0 plus 1. That is P orbitals 3 na, Px, Py, Pz. Understood? Orbitals means, if you represent orbitals means Px, Py, Pz. The second means 2Px, 2Py, 2Pz. Understood? Because second shell na 2Px, 2Py, 2Pz. Understood? So every P orbital, suborbital contains 2 electrons. No? Now 2 electrons are there. One spins in clockwise, one in anti-clockwise. For Px, plus half, minus half. Py also, plus half, minus half. Pz also, plus half, minus half. Remember this. Very, very important. If you remember all these, then the Pauli's exclusion principle is very, very easy. I hope you all understood my explanation related to Pauli's exclusion principle. If you understand my explanation, please like, share and subscribe and even comment in the comment section. Thank you.